Hey, it's Mr. Trammell. In this video, I wanted to quickly show you how to work through about 4 of the examples that are similar to your formative assessment that's on the TeacherMade website. So this first one here, if we're trying to solve for x or a variable, we want to be able to get the x's on the same side. And first we notice that each one of these has parentheses, so we know that we're going to have to distribute first. So I'm going to go ahead and rewrite this. So 3 times x is 3x. 3 times -2 is -6, and that plus 4 still stays on that side. On the right side now of our equal sign, 4 times x is 4x, and 4 times -1 is -4. Okay, now I'm looking to combine like terms, if there are any. I can pretty quickly see that on the left side, we have a like term here and here, so I'm going to go ahead and combine those before I do anything else. And so I'm still going to have 3x. Now, -6 plus 4 is -2, and that's equal to still 4x minus 4. Now we want to get the x's on the same side of the equal sign, so I'm going to move this positive 3x, and I know I can make this number go to 0 by subtracting 3x, right? That goes to 0. But what we do to one side of the equal sign, we have to make sure that we do to the other. So I'm going to also subtract 3x from here. Everything else is going to stay the same, so I'm going to bring down our -2 and eventually our -4 as well. So on the left side, all we have is -2 equals, now 4x minus 3x is 1x, and -4, again, we haven't done anything to. Next step would be to try to get the x by itself. Notice that if here is our x, then that -4 is on the same side of the equal sign, but outside of that box. So I'm going to add 4 to both sides, and we're going to get that x equals, well, -2 plus 4 is 2. Okay, let's take another look at a different problem. This one starts with a number out in front, so our constant is actually out in front, but we have a negative sign followed by something in parentheses. Well, just like in the last example, if we had something in parentheses, right, we knew that we would want to distribute, but in this example, we're not going to distribute the whole 13 through that. We're only going to distribute the number that's out in front of the parentheses. So if it helps to write it like this, where there's a -1 right here. Remember, if you don't see a number in front of that, then we can assume that it's 1. So really, we're distributing -1 through to everything in the parentheses. So we're going to get 13, right? Still haven't done anything with that. -1 times 2x is -2x. -1 times +8 is now -8. And again, the right side of our equal sign, haven't done anything to yet, so that's going to stay the same. Now, our next step, let's go ahead and combine like terms with what we have. This is a like term, and those are on the same side of the equal sign, so we can go ahead and combine those. 13 minus 8 is going to be 5. So 5 minus 2x equals 3x. Okay, notice that now I'm going to try to move my x from the left side of the equation to the right side of the equation. So I'm going to add 2x to both sides. And when I do this, right, this one goes to 0, which is what we want. However, on the other side, this is going to add to 5x. So on the left, we still have this 5. So 5 equals 5x. And we want to be able to now get the x by itself. And we know that we can divide by the coefficient that's in front of x. But what we do to one side, again, we do to the other. So 5 divided by 5 is 1. On the right side, we're left with x. And again, 5 divided by itself is also 1. So for a second example here, x equals 1. Okay, let's take a look at one more. Here we have the distributive property still, but we're dealing with fractions now. So just like you would normally, let's go ahead and distribute whatever's in front of the parentheses through to everything that's there. So in this case, 1/4 times x is still 1/4 x. And 1/4 times 32 is 32 over 4, but we know that 32 divided by 4 is just 8. So I'm just going to write 8. Okay, and on the right side, this is still equals to -7 over 4 x minus 4. Okay, and I know that there are fractions in there, but we're still dealing with this the same way that we normally would. So we're going to get the variables on the same side. I'm going to choose to move the one on the right this time. So I'm going to actually add 7/4 x. Remember to keep the x with it. But I'm going to add that to both sides. And so where I add that here, I'm also going to add it on the left side. So plus 7/4 x. Right, well, the good thing of what happens on the right is that this now goes to 0. So on the right side, we're only left with -4. But on the left side, we have 1/4 plus 7/4, which is 8/4. And again, because both of those numbers are divisible by 4, we're just going to rewrite that as 2. So 2x plus 8 is on our left side, and -4 is on our right side. Right. Well, now we can set this up as a two-step equation. We can solve for x by getting the variable by itself. So we can subtract 8 from both sides. We get that x equals 2x equals -4 minus 8 was -12. So our last step here would be to divide both sides by 2. And we get that x equals -12 divided by 2, or -6. Okay, our last one here is a word problem. We have to create the expression and then, of course, solve for it. So let's go ahead and do that. So this says that Terry was selling bags of popcorn for a school fundraiser. He sold 9 more medium bags than small bags, but 3 times as many large bags as small bags. If the small bag costs $2, the medium bag $4, and the large bag costs $6, right? We have to figure out how many small bags of popcorn were sold, knowing that Terry made $180 total. Okay, so let's try to break this down and only look at it piece by piece, right? First, let's write an expression for the number of small bags. Okay, so if we're looking at this, we don't know how many he sold, but we do know that all of them are dependent on the number of small bags that are sold. 9 more than or 3 times as many. So we're going to make the number of small bags, right? Number of small. We're going to make this our variable. So I'm going to choose x. Okay, so let's go ahead and do the same for our number of medium bags. Right? We're going to take this. Now we know that from this beginning sentence, or second sentence rather, he sold 9 more medium bags than small bags. Right, so this is now the number of small bags, x, plus 9. Okay, and finally, our number of large bags sold, okay, again, 3 times as many large as small. Okay, so this is x, but we're multiplying that by 3, so 3x. Now we have the expressions for the number of bags sold. But let's go ahead and associate our cost with each one of these. So we know that our small bags, however many are sold, cost $2 each, right? Our medium bags, let me put the word each here. Our medium bags cost $4 each, and our large bags cost $6 each. Okay, well, now we know that with a cost associated with that, right, that our grand total should be equal to $180. So let's see if we can now create an equation where the left side determines what we had up here, and our right side is still equal to $180. Okay, we know that the number of small bags was x, and that each small bag cost $2. Right, so our total cost for all the small bags is the $2 times however many were sold. Okay, well, we can do the same with our next one. So we can say plus the number of medium bags, right, which was x plus 9, times the cost for each medium bag sold, which was $4, right, $4. Okay, and finally, we can take the number of large bags sold, 3x, times the cost for each large bag, $6. Okay, and this is the most difficult part. This is setting up the equation. Again, what we have so far is that the cost per each of the small plus the cost per each of the medium and the cost per each of the large, right? That's going to give us our total number of bags sold. Now we have this just in terms of the connection to the smalls. So we can go ahead and we can solve for X, right? So I'm going to scroll down here and I'm going to go ahead and distribute, right, where I see parentheses. So $2 times X, still there. Now we have $4 times X plus 9. Well, 4 times 9 is 36, so this is plus $36. And again, now on the right side over here, we have, and here on the right, we have plus 6 times 3x, so 18x, right? And again, this whole thing needs to be equal to 180. Okay, well, let's go ahead and combine like terms on, for our variables here, we have 2x, 4x, and an 18x, right? 2x plus 18x is 20x, so plus 4 is 24x, plus 36 equals 180. Now we're going to subtract 36 from both sides, and we get 24x still on the left equals 144. Well, we know that we can divide both sides with a number that's out in front of x, so this is 24. And when we do this, this number goes to 1, which is good because that means on the left side, all that's left is x. And on the right side, 144 divided by 24 is 6. Right, so x equals 6. And again, x is our number of small bags sold. Okay, remember that you can always go through and recheck your work by submitting whatever you solved for X. You can substitute that back in everywhere that you see X, and you should be able to get the same thing. Hope this helps.